Assalamu alaikum. We are proud to represent Comsat's University Islamabad, WA campus, under the esteemed Department of Electrical and Computer Engineering. Our project is Grid Fusion, AI-based SaaS technology for the national grid. Our team includes Taha Yassin, Fuzan Mujtaba, Syed Ikrar. Guiding our efforts is our project lead, Dr. Muhammad Iqbal. Assisting us are our advisors, Dr. Umair Javed, Dr. Zeshan Kaleem. Background: in Pakistan, electricity is generated by GENCOs and IPPs, and then transferred to grid stations, which step up the voltage level to 220 kV and 500 kV and transmit it to primary distributors, NTDC. The voltage levels are then reduced to 132 kV and distributed to all the discos. The discos then step down the voltage to 11 kV and distribute it to the users. If any issue occurs at any end, either at the generating station, generation grid, primary distributors, secondary distributors, or at any transmission line, or due to maintenance of any equipment or any other error for which we have to isolate a line, we have to inform NPCC. The current manual process of managing power failures and isolating lines is slow and inefficient. It can take hours to take corrective action. Making a schedule and starting other generating units is also slow, which can lead widespread power outages and inconvenience to users. There is also a risk of human error during this process, which can further compound the problem. Methodology: we have created a web app for displaying the grid data. We will connect a microcontroller with CTs and PTs with the existing CTs and PTs of the grid. Our CTs and PTs will collect the voltage and current readings, process them to calculate the power and power factor. Then we will use a microcontroller to fetch the data from that microcontroller to our main controller with communication protocols. Our main microcontroller will upload that data to cloud. Then from that cloud, our app will fetch the data. Then the app will run a script to forecast the electric load. Then from that forecasted load, our app will make a schedule of load shedding. Script will contain machine learning algorithms for load forecasting. Our design system will connect within the electric panels of an existing grid station. Then it will be connected to Wi-Fi and send the grid data to Firebase real-time database. Then a cloud-based virtual machine will read those data from server and then use our AI model to predict the future load. Here is the hardware. First of all, we have 220 volts, which we use to represent 220 kV. The voltages are then passing through a current transformer, which reduces the current to a measurable range, and our control panel measure that current. Then the voltages are passed through a circuit breaker. Then we have 220 kV bus bar. A PT is also connected in parallel to measure voltages. Then we have 220 kV to 132 kV step-down transformers. Then we have 132 kV bus bar. Again followed by a current transformer, a circuit breaker, and also a potential transformer is also connected. Then we have an isolator, after which we have 132 kV line going out. Here is our main control panel, which is equipped with a Node MCU ESP32, current transformer, potential transformer, and also relays which are used to control breaker. Then from that grid station we receive voltages in a 132 kV to 11 kV secondary grid station. The arrangements remains the same. First a CT is connected in series with a circuit breaker. Then a bus bar with a PT and a 132 kV to 11 kV transformer. The 11 kV feeders are then sent out from the grid. Now we have our control panel, which is equipped with same current and potential transformer. Along with that, Arduino Uno with ESP8266 is also used in this control panel. Then energy meter is connected to measure the energy being used at each feeder. This is our server. The exact readings are measured and displayed in this server. Then our app reads the values from that server and convert them into voltages and currents in accordance with the CT and PT ratio of transformers. The AI models also reads these values and predict the load according to that load and send the predicted load along with the load shedding schedule to our app. All the readings from the control panel are sent to the real-time database. We can see that the values are being updated in the real-time database. These values along with historic data is now imported into MATLAB. That data is used by our AI model to train itself. An Excel file of predicted load is generated by our AI model. The data is transmitted to our app, where users can access a comprehensive display showcasing the forecasted load, as well as the specific hours during which electricity shortages are anticipated. Here is the preview of our app. Thank you for watching.